Hello and welcome to Algebra 1 Transforming Exponential Functions. In this video we're going to use properties of exponents to transform expressions for exponential functions, and we are going to convert compounded interests with different numbers of periods to compare them. This is one of the standards we are going to be hitting in this video, and this is from the Florida's Best Standards for Mathematics, and then depending on how you use this video, you can also hit some of the thinking and reasoning standards. So let's go ahead and get started. So let's say that Bank A has a 0.15% interest compounded monthly, and then we have Bank B with a 2% interest compounded annually. And so with this, you cannot just multiply what percentage you have monthly by 12 to make it annually. You have to do a little bit of a conversion. And so let's go ahead and get these both into annual. Let's first think about what we need to do. We've got 0.15% compounded monthly, and we're trying to get that to annually. So let's start out with one of the formulas that we have kind of been working with already. So we know that this is going to be an exponential function that is growing, and so we have this principal amount, or what we're starting with. So that's our starting point. Our starting point really doesn't matter because we are going to assume that whatever point we're starting with, it's going to be for Bank A and Bank B. So that A is kind of just going to disappear. And so we're just going to have 1 plus, and then let's go ahead and take that 15%, that 0.15%, and change it to a decimal. And so it's going to be 0.0015. And then let's think about how we would go from monthly to annually. And you would multiply by 12. And so this is now going to be raised to the 12th power. And then on the outside, you're kind of doing the opposite. And what you're doing on the outside is not going to matter in the grand scheme of things, and you'll see why in a second. But you're thinking about, okay, so if t is representing the years, you would be dividing by 12 to kind of represent what's happening annually. And then, so here, when we go to distribute this anyway, 12 times 1 over 12 is just going to be 1. And so really you have 1.0015 raised to the 12th power and then times t. And then you're going to take this and put this into your calculator. And when I put this into my calculator, I have 1.0015, and then I'm going to raise that to the 12th power. And so this is what I end up with, 1.0181. And then raised to the t. And then, so now from here, what I have behind the 1 is now my new interest rate. And so that interest rate is going to be 0.0181. To get that back into a percent, I can multiply by 100 or move that decimal back to the right. And so I have a 1.81% annual interest rate. So this is now and now I can compare these. And so Bank A has a 1.81% annual rate, and then Bank B has a 2% interest annual rate. And so for this one, Bank B is better. And so let's talk about whether or what would happen if these were both monthly. And so we're kind of doing the opposite with this one. We're starting with a 2% compounded annual interest rate, and we're trying to change that to monthly. And so I have A equals, and then remember that principal amount doesn't matter anymore. And then it's going to be 1 plus that 2%, which is 0.02. And then to go from annually to monthly, you're going to divide by 12. And so if we're dividing by 12, that's the same thing as like multiplying by 1/12. And so that's going to be multiplied by 1/12 as our exponent. And then if we're thinking about annually to monthly, we're kind of multiplying that t value by 12, which of course doesn't matter in the grand scheme of things, so don't forget that part. And so we've got 1.02 to the 1/12 t. And then from here, I'm just going to throw that into my calculator. So 1.02 y to the x, and then don't forget that this needs to be in parentheses. So when you have that 1.02 y to the x, make sure you hit parentheses and then 1 divided by 12, close parentheses, and then make sure you hit that equals at the end. If you don't, it's just going to show you what 1 divided by 12 is, so just be careful. And so this is going to be 1.001651. And so and then we're going to put that t on there. And then remember, this is your interest rate. Everything after 1 is your interest rate. And so for this one here, it's now 0.001651. And then if I multiply that by 100, I get 0.165%. And so this is now 0.165% monthly. And now it makes it a lot easier to compare. So now I have 0.15% and then I have 0.165%. And so which bank is better? It's still going to be B. So it doesn't matter whether I changed them both to monthly or if I changed them both to annually, it still gave me as bank B as being a better interest. So let's do another one. And so we have 0.16% compounded quarterly to annually. And so I have A equals, and then thinking about how we go from quarterly to annually, I'm going to be multiplying by 4 because there's 4 quarters in that annual amount. So that's going to be 1 plus, and then let's take that 0.16%, and that's going to be 0.0016. And then we're going to raise it to the 4th because we're getting to annually. And then this would be a quarter. And then we've got 1.0016 to the fourth t. We're going to throw that into our calculator. So 1.0016 raised to the fourth power, and we get 0.006415. And then this becomes my new interest rate. We multiply it by 100 to get it back into a percentage. And so that becomes 0.6415%. And then it's now annually. Okay. All right, let's try another one. So convert 3.14% compounded annually to semi-annually. And so to get from annually to semi-annually, we are going to divide by 2. And so that's going to be 1 plus, and then we've got 3.4%, and that's going to be 0.034. Okay, because we're taking that annual amount and we're dividing it into 2 separate payments, and that's how we get annually. And so we're going to multiply it by 1/2 because that's the same as dividing by 2. Then we do the opposite on the outside. Don't forget to put fractional exponents in parentheses when you go to put it in your calculator, so just be careful. And so when I go to put this in my calculator, 1.034, and then y to the x, 1 divided by 2. And then this is my new number, 0.01685. This is my new rate. And then we multiply it by 100 to make it a percent. And so this becomes 1.685, and then that would be a I would just round it, so I'll go ahead and just make this a 9%. And then that would be semi-annually. Okay, so for these, just kind of be careful because you're not just cutting things in half or dividing things by 4 or multiplying things by 4. You're going to have some extra decimal points on the end. So it's not as easy as just kind of doing the math. It could be close, but it's not always going to be exact. So just kind of be careful. When I'm doing something like this first one, when I'm looking at this first one, I can't just say 0.16 and then multiply it by 4. That would only give me, and I'll show you, it's going to be if I took 0.16 and just multiplied it by 4, I'm going to get 0.64. But when you guys take your test, that answer is going to be on there, but they're looking for something more like this, where you're going to see something like 0.642% annually. For this one, same thing. If I were to look at this one and do 3.4, and then divide it by 2, I get 1.7, and they're going to have 1.7 on there, but then they're also going to have the choice of something more like this. So just be careful. Your answers are going to be close, but if you're dealing with multiple choice, you're going to get multiple answers that have very similar or very close values. So just be careful with that one. But this one wraps up our video on converting these compounded interests into different time periods.